Hello, my name is Vadim Tynchenko. I'm an associate professor from Reshetnev University, Krasnoyarsk, Russia. We would like to present you our study called Software for Optimization of Beam Output during Electron Beam Welding of Thin Wall Structure. So let's start. Our work is devoted to the issue of beam output optimization during electron beam welding of thin wall structures. Authors developed a model for optimizing the electron beam output mode, which considers the dynamics of the thermal processes in the welded joint zone and depends on the electron beam input mode, the geometric dimensions of the product, and the technological parameters used in the welding process. This slide presents a block diagram for setting the beam output parameters. The program has the ability to load the previously saved beam input-output parameters from the database. If you don't need to load parameters from the database or it has been loaded, then the operator has the opportunity to manually enter the time of input and output of electron beam, or use the optimization block and enter the seam length, seam width, product thickness, and physical properties of the material, as well as the input time ray. Next, the parameters of the genetic algorithms are introduced. It's the number of individuals in the population, the number of generations, the type and parameters of selection, the type of recombination, the type of parameters of mutation. And after that, the optimization of the beam extraction process is performed. After the optimization of the beam output has been made, or the input and output times are entered manually, it is possible to save the current values of the parameters in the database. Then the values of the input-output parameters of the beam are recorded, and a mark is put in the item parameters of the input-output of the beam. This slide presents the classical electron beam injection control. First, the beam input flag is set, then entering the input time and IB are set to 0. Next, the number of steps of the beam input is calculated, and the following values are set for the focusing current and the welding speed. At the next stage, the value of I is compared with the previously calculated number of steps until the condition is met. I is greater than n step input. Until I is less than n step input, the beam current is calculated using the formula in step 7. At stage 8, an increase in time is made by a time delta t. Then I increases by 1 until the condition I is greater than n step input is met. This slide presents a block diagram of the optimization of the beam extraction process. In the sub-process of modeling the cooling temperature, which is figure T input cooling, the temperature is calculated using the formula for the distribution of the temperature field at the stage of beam output. Next, the initial population of individuals of the genetic algorithm is formed in a random way. The phenotypes are calculated for individuals of the population. Then, in the next sub-processes, the temperature is simulated, introduced at the stage of ray output for each individual of the population. Next, the fitness of individuals in the population of the genetic algorithm is assessed. An individual is selected according to the criteria. If the condition for the end of the search is not met, then the genetic operator is applied. That is, crossing is applied. In the crossing operators, 1-2 offsprings are generated to reduce the time complexity of the algorithm. And mutation, which is changes an arbitrary number of elements in the individual to other arbitrary ones. Also, a transition to the stage of calculating the phenotype for individuals in the population is made. Otherwise, if the search condition is satisfied, then an individual is selected from the approximation of Pareto set with the minimum CT joint. After that, the optimal values of the ray output shape function are displayed, which is f opt I out from Ti, are derived for all times of the output of the beam Ti. This slide presents a block diagram of the electron beam extraction control with optimization. At the first stage, the following parameters are set: IB, IF, and V, which is velocity. Then entering input time. Next, I is equated to 0, and at the stage 4, the number of beam output steps is calculated according to the formula presented in the block diagram. Then, while the condition at the fifth stage I is less or equal to the n step output is true, the sixth, though the 8 stages are performed, namely calculating the beam current IB and increasing I by 1 until I is greater than n step output. Then IB, IF, and velocity is assigned to 0 and the control ends. The assignment of fitness to individuals in the population is carried out in accordance with the schema in the Fonseca and Fleming's multi-objective genetic algorithm, FFGA, which is used in this work. This slide presents the optimization criteria. The prototype of the software system is designed to control the process of electron beam welding of thin bolt structures based on mathematical models and algorithms for controlling the modes of electron beam output. This paper considers the limited functionality of the system presented by the program, namely the automatic parameter setting model, in which the stage of electron beam extraction is optimized. In this case, such a parameter is optimized as the time of output of the beam during electron beam welding in order to prevent effects arising at the stage. Microtracks, voids, lack of penetration, setting of the seam. The slide presents a prototype of the software system. So the next slide presents the optimization window of the software system. The system allows you to form a discrete optimal trajectory of the beam output. On the presented form, the material for which welding will be performed, aluminum, titanium, copper, stainless steel, and other alloys, is selected. Thermophysical parameters are also set. The system substitutes already known values from the database, but it is possible to set them manually. A genetic algorithm is used to optimize the output of the electron beam. Its configuration is also available in the manual mode, so you can set the following parameters: number of generation, population size, selection type, crossbreeding, mutation, consideration of restrictions. Optimization results are displayed in the form of table. So, in the course of study, the authors developed a model for optimizing the electron beam output mode, which considers the dynamics of the thermal processes in the welding joint zone and depends on the electron beam input mode, the geometric dimensions of the product, and the technological parameters used in the welding process. The prototype of the software system developed by the authors will allow obtaining a stable quality of the welded joint and reducing the number of defects arising in the stage of electron beam extraction. So, thank you for your attention and goodbye.